Myself, Dr. B. Shekhar, working as an associate professor in the Mlritm, Hyderabad. Last time we are discussed about the one of the important topic, that is batteries and corrosion. After that session, I want to explain about the first module, that is nothing but the one of the most important module for the BTech students, and one of the most important engineering material, that is water. Once again, welcome to this session. Today in this session, I want to explain about the water and introduction of the water, and how that water is converted as a hard water. We called as a hardness of the water, that is first student. And we want to estimate that hardness of water by one of the complexometric titration method, that is EDTA complexometric titration method, along with that specifications of the potable water. Potable water nothing but the drinking water, which kind of the characters need a drinking water. That topic also we are covering in this today's session. After that, how we are preparing that potable water in the by using the water technology or water treatment. Further, in these steps involved in the treatment of the water also we are discussed in this topic. Up to this topic we will discuss here. If you want to see, all you are known, water is a essential for all the living and non-living organism. Water is a crucial for every human being. Water is a crucial for the every human being. Almost all human activities, domestic and agricultural and industries, are using water as a main source. To living organism, to living, they are using water. For agricultural, for paddy or other agricultural purpose also we are using the water. Along that, the industries persons, the industries also, they are using water as a steam, mainly steam agent. And in this, you all are known, in this earth less than 1% water is available as a drinking water. Although water is a nature's most wonderful and abundant component, but only less than 1% of the world water resources is available for readily use. Means in 100%, only 1% of the water is readily available for the drinking water. So remaining all 99% water we are considering as a non-consumable water. Means that is we called as a hard water. So because of that reason, we are studying or we are treating that water as a important to discuss in this topic. Therefore, water needs to be treated to remove undesirable impurities. That removable undesirable impurities we called as a water technology or water treatment. So how that hard water we are converting into soft water, the technology, the treatment we called as a water treatment or water technology. And how the rainwater, you all are known, the rainwater is pure water. But that rainwater, when it's touched to the earth, the rainwater, the soft water, it is converting into hard water. How that soft water is converting into hard water? To understand that one, here the mainly we are talking about the three type of the impurities we are mentioning here. One is physical impurities. The second one is chemical impurities. The third one is biological impurities. So in these chemical impurities or physical impurities in biological impurities, we will see above first is mean physical impurities. What is mean by the physical impurities? When we are talking about the physical impurities, we are talking about the color of the water, turbidity of the water, odor of the water, and taste of the water. We are considering as a physical impurities. And coming to the mainly, we are talking about the chemical impurities. Yet mainly we want to talking here about the chemical impurities. That chemical impurities also some we called as a inorganic chemicals or organic chemicals. When these chemicals, especially in the form of agriculture, when we are using in agriculture like chemicals, pesticides, other like drug industries and textile industries and the petroleum industries and dyes and paint industries, when they are mixing with water, they are the mainly responsible for the chemical impurities. And coming to the third type of the biological impurities is nothing but these pharma related biological impurities, or if they are algae or pathogenic bacteria or fungi or virus, and these mainly the hospitalities. The hospitals, if they are dumping the biological impurities in that water, due to that biological impurities are responsible for the grow up in the algae bacteria into that water. Mainly these three are the physical and chemical and the biological impurities, they are responsible for the hardness of the water. So in this first module in water and treatment, we are always talking about the hardness of the water. What is simple definition and easy definition to express what is mean by the hardness? Water which does not give lather with soap. Water which does not give lather with soap, we called as a hard water. Water which give lather with soap, we called as a soft water. By simply when we are seeing the soap is mixing with water, if it is producing lather, we call as a soft water. If water doesn't give lather with that soap, we call as a simply hard water. By physically we are saying to say in the form of chemical formulas. In the form of chemical formula, what is mean by the hardness? Again, this hardness are two types. One is temporary hardness, another one is permanent hardness. One is temporary hardness, another one is permanent hardness. In this temporary hardness, mainly we are talking about the carbonates and bicarbonates. If water contain along with metals and these carbonates and bicarbonates, we called as a temporary hardness. We called as a temporary hardness. Once again, I am telling you, if water contain metals along with carbonates and bicarbonates, we are saying a temporary hardness. Water contains metals along with chlorides, sulfides and nitrides, we called as a permanent hardness. We are saying as a permanent hardness. This temporary hardness also called as a bicarbonate hardness. The temporary hardness also called as a bicarbonate hardness. Why? Because the carbonates are present in that water. Due to that reason, the temporary hardness also we called as a bicarbonate hardness. And this temporary hardness we are removing easily by the boiling of the water or blow down the operation. Means that used water we want to remove. By these two simple techniques, we are removing the temporary hardness from the water. But when coming to the permanent hardness, easily by the blow down operation or boiling, that is not possible to remove the permanent hardness, because they are sticking in that water. To remove that permanent hardness from this water, we want to use some chemicals, some suitable chemicals we want to use. When we are using that suitable chemicals, the water dissolved impurities, they are converting into non-dissolved impurities. The water dissolved impurities, they are converting into non-dissolved impurities. That non-dissolved impurities, again by the blow down operation or filtration, we are removing easily. Like this, the two type of the hardness, that is temporary hardness and permanent hardness, we are seeing. And what are the units? What are the units we want to express the hardness or expressing the water? That is ppm, that is parts per million. That is parts per million, one unit we are using. The another one unit is mg per liter. Another one is mg per liter, that is nothing but the milligrams per liter. The third one is degree Clark. The third one is, that is degree Clark, and the fourth one is degree French. The fourth one is degree French. These four units we are using as a water units. And what is the relation between these four units? What is the relation between these four units? We want to say simply 1 ppm is equal to 1 mg per liter. That 1 mg per liter is equal to 0.1 degree French. That 0.1 degree French is equal to 0.07 degree Clark. It is a relation we have between the units. After that, up to this, what we are discussed? We are discussed about the hardness of the water. We are discussed about the hardness of the water. Now it's a time to estimate. If they are given one unknown sample and they are saying this unknown sample, you can find how much of hardness we have. So for that we are using so many other methods we have, but now in this we will see about the one of the method to estimate the hardness, that is nothing but the EDTA method. That is nothing but the EDTA method. EDTA method also we called as a complexometric titration method. The complexometric titration method, why we are saying the complexometric titration method? Means in the products we are getting the compounds as the end products. So in this, what is mean by the EDTA? We have here the structure of the EDTA. Based on the structure, what we are given name to this compound, that is ethylene diamine tetraacetic acid. Ethylene diamine tetraacetic acid, it is a abbreviation or full form of the EDTA. The E stands for the ethylene, the DE stands for the diamine, the TE stands for the tetra, the AE stands for the acetic acid. So now the ethylene diamine tetraacetic acid, why we are given this name to this compound? Because here we have the two carbons, the meth-eth. The ethylene is present. The ethylene is present and two amine groups are present. So we called as a diamine and 4 acetic acid. 4 acetic acid, CH3COOH, 2 valency of the carbon, we are written as a CH2COOH. 4 acetic groups are present. So because of that reason we called as a tetra. Tetra means 4. Ethylene diamine tetraacetic acid. It is a full form of the EDTA. And what is the principle behind in this experiment? How we are estimating the hardness by using this EDTA method. In this, when we are doing in the EDTA method, what we are doing to easily understand 4 steps we are follow in this procedure. Total 4 steps are we are following in the steps. The first step, we are preparing the hard water, and second step, we are estimating the EDTA, and third step, simply estimating the total hardness, or if you are estimating here total hardness, if you want a permanent also, the fourth step, estimation of the permanent hardness also we are doing in this method. So before going to this procedure, this methodology, what is the principle we have in this experiment? In this, what we are doing, we are taking a burette. In this burette, we are filling the EDTA solution. We are already preparing that maybe some 0.01 or 0.02 or 0.05 or 0.1 molarity or normality of the EDTA solution we are preparing, and we are transferring into the burette. Then we are taking a fresh conical flask. We are taking a fresh conical flask, and that fresh conical flask, what we are doing, we are adding 20 ml of the hard water. We are adding the 20 ml of the hard water. The 20 ml of the hard water we are expressing in the form of presence of metal. Metal is present in that water. Again, this 20 ml water, again we are adding 2 to 3 ml of the buffer solution. 2 to 3 ml of the buffer solution we are adding, and along with 2 to 3 drops of the indicator, that is EBT indicator we are adding. When these 3 chemicals we are added to the conical flask, that is turns to the wine red color. That is turns to the wine red color. This diagram is showing that wine red color. And when we are doing this experiment, we are adding the 2 to 3 ml of the buffer. So what is the use of the buffer? When we are adding buffer to a solution, the buffer will helps us the constant pH. Constant pH. In this experiment, we are using the mixture of ammonium chloride and ammonium hydroxide, combination of ammonical buffer solution we are using. When we are using that buffer solution, the pH is 9 to 10. We are maintaining in this experiment. And also we are using the EBT indicator. EBT means eriochrome black tea. Eriochrome black tea indicator we are using. What is the role of the indicator? Indicator indicates completion of the reaction. Indicator indicates completion of the reaction by changing the color or changing the physical state. So in this, when these 3 chemicals we are added, like say consider it is the first conical flask, it is second conical flask, it is third conical flask. When we are these 3 chemicals added to the first conical flask, it will convert as a wine red color. The wine red color means nothing but the metal contain EBT. The metal containing EBT, we are first reaction we are get. And this metal contain EBT titrate against with burette containing EDTA solution. This wine red color turns to the blue color. This wine red color turns to the blue color, but this blue color is not responsible for the metal containing EDTA. It is blue color is due to the free form of the EBT. Free form of the EBT. That EBT that is responsible for this blue color. That EBT is responsible for the blue color, like these two steps. The step 1, step 2 are reaction 1 and reaction 2. These two reactions are behind in the complexometric titration method. And already I said the 4 steps in this. We want to estimate the total hardness and temporary hardness or permanent hardness. In this we are doing a 4 steps. That part we are doing in our lab session. We will deeply discuss in our lab. So next, here we want to discuss about the specifications of the potable water. Means another word, say characters of a good drinking water. If you want to consume a drinking water, what are the characters that drinking water should contain? We called as a specifications or characters of a potable water. The another we want to say the potable water, also called as a drinking water, or simply in our metropolitan cities we called as a municipal water. Here the first we are always talking about the color and order. And color and order. The soft water should not contain any color, means colorless and orderless. It should not contain any color or any order, but it is pleasant to taste. That is a first character we are talking about that. And we are talking about the drinking water pH. Simply the 7 to 8 or 7 to 8.5 nowadays we are considering as a drinking water pH. And also we are talking about the hardness. The hardness is less than 150 ppm. The less than 150 ppm we called as a, that is a also acceptable hardness in the drinking water. And the turbidity should be less than 25 ppm. The turbidity is less than 25 ppm we are considering as a, that is also good character. And the water must be free from the pathogenic bacteria. The third type of the impurity, it should be free from the pathogenic bacteria. And another one, the water should be free from the dissolved gases. It should be free from the dissolved gases, and it should be free from the objectable minerals. Minerals are good from the health, but some of the bad minerals also we have, so you should not include that objectable minerals in this water. These are some of the important characters of a drinking water. And according to my knowledge, all who are preparing the water bottles or who are the water supplies, I think they are following these characters when they are preparing the drinking water. Another word we want to say, guidelines from WHO, World Health Organization. These are guidelines given by the WHO, World Health Organization. And how that hard water we are converting into soft water. So that was happened by these steps. In this, what we are doing, we are talking about the step 1, that is nothing but the screening. And the second step we are talking about the aeration. And the third step is sedimentation. The fourth step is coagulation. The fifth step is filtration. The sixth step is disinfection or sterilization. By using these 6 steps, we are converting this hard water into soft water. Now we will discuss deeply step by step. First, what is mean by the screening? That is, I'm say is step 1. What is a step 1 in the specifications of the potable water? Steps involved in the treatment of potable water. The first step is screening. Screen means the itself it is giving answer to us. We are using screens. The screens are helps to remove the large number of impurities like wood pieces, leaves, and any other heavy particles. The floating materials, simply we called as a floating materials. If that floating materials are present in that water, the waters are we are using in the screens. We are using the screens. The screens have the large number of holes. The holes are removing. The holes are stopping the floating material. So in the first step, we are removing the floating material. The floating material we are removing with the help of the screening. The second one is aeration. Aeration. The second step is aeration. Means we are exchanging the air, water containing air, water dissolved air. We are exchanging by the environment containing water. Means environment contain high number of oxygen. So the high number of oxygen we are exchanging with this water. So the oxygen concentration we are increasing in our water. So that is nothing but the aeration. Aeration means this water is exchanging the gases, exchanging the air between the hard water and environmental contain oxygen. And the third step, in the third step, what we are not doing, simply that water up to 2 to 6 hours without any disturbance. We are taking the water in the big size of the vessels or container, and simply we are not disturbing that water up to the 2 to 6 hours. So on that time what happen, if that water containing any impurity, any mold particles, they are settled down at bottom of the tank. At the bottom of the tank they are settled down, and simply the upside water we are taking for the next step. In the fourth step, coagulation. Coagulation means nothing but we are using the coagulants. We are using the suitable chemicals. We are using the suitable chemicals. By using these suitable chemicals, the water contain dissolved impurities. The water contain the permanent hardness causing substances and temporary hardness causing substances. They are the dissolved impurities, they are converting into water indissolved impurities. So for that, what are the coagulants? We are using alum. Alum we are using in Nalgonda technique, and the sodium aluminates. Alum and sodium aluminates, these type of the coagulants we are using in this step. When we are using these chemicals in this coagulation step, these chemicals are reacting with water containing chemicals and they are separated out. They are separated out, and that particles we are removing. And after that, to remove that settled particle, we are doing our fifth step, that is nothing but the filtration. It is nothing but a simple, we are using the mesh, we are filtering that water. Due to that filtration, we are removing the undissolved the chemical substances if they are present in that water. Up to fifth step, what we are done, we are remove the floating material in step 1. In second step, we are increased oxygen concentration. In third step, we are removing the mud particles, sand like that, and with the help of fourth and fifth also we are remove the chemicals in that present in water. Up to the fifth step, we are remove the chemical substances in that water. So Next, that is sixth step, or we consider as a special topic, that is the disinfection. So chemicals, when we are remove the chemicals, but we are till now we are not remove the biological impurities. The third type of the water impurities we called as a biological impurities. We are not remove that biological impurities. Now it is a time to remove that biological impurities. To remove that biological impurities, what we are doing, that water after filtration, that water we are treating with chlorine. Chlorine in the form of chlorination, in the form of chloramine, in the form of bleaching powder. These are some of the different types we are using to disinfect that water. But in the chlorination, in the chloramine, and in the bleaching powder, the chlorine is main agent present in that water, and this chlorine reacting with water, and we are always in the chlorination or in the chloramine or in the bleaching powder, we are getting the HOCl, that is hypochlorous acid. This hypochlorous acid is responsible for the kill the pathogenic bacteria. It is a disinfecting agent. Hypochlorous acid, HOCl, that is hypochlorous acid, that is a disinfectant agent. That disinfectant agent is kill the bacteria. And another type of the boiling also. The second type, if you are boil the water up to the 100 degrees centigrade or above 100 degrees centigrade, it is also another type of the method to remove the pathogenic bacteria. And another type of the disinfection process is nothing but the ozonization. Ozonization. In this, the water is we are treating with O3, that is nothing but the ozone. When that water treated with ozone, the ozone is releasing as a oxygen and nascent oxygen. Monomer of the oxygen we called as a nascent oxygen. This nascent oxygen also act as a disinfectant agent. This nascent oxygen is kills the bacteria. Already I said in the chlorination and in the chloramine and bleaching powder, you can see here we have the chlorine. Chlorine is treating with a hard water and it is giving the hypochlorous acid. This hypochlorous acid is kills the bacteria. In this chloramine step also, in the chloramine step also, 2:1 ratio, 2:1 ratio of chlorine and ammonia. We are getting the chloramine, and when this chloramine is reacting with water, again we are getting the HOCl, that is hypochlorous acid. And in the bleaching powder also, we are getting the hypochlorous acid. So this hypochlorous acid is a disinfectant agent. By using this disinfectant agent, means in the chlorination we are removing the pathogenic bacteria. It is I said it is a bleaching powder. When we are using the bleaching powder also, calcium hypochlorite, the bleaching powder, when we are using this bleaching powder also, this bleaching powder is reacting with water and we are getting HOCl, hypochlorous acid. The hypochlorous acid is kills the pathogenic bacteria. Means in chlorination, different chemical we are using. In bleaching powder, we are using different chemical. In chloramine, we are using different type of the chemicals, but the product is only one, that is hypochlorous acid. It is killing the bacteria. It is killing the bacteria. And this is about the disinfection. I hope you understand up to this topic. In this, up to this, according to my knowledge, I think you understand about the what is mean by the hardness of the water. And first, why we are talking about the, why we are discussing about the water. Already according to our knowledge, water is a species in this earth. It is a nature given gift to us, but very less amount of only 1% of the drinking water available in this earth. So remaining 99% hard water we have. How that 99% hard water we want to convert as a soft water, that we called as a water treatment or water technology. So I hope you understand about the what is mean by the water, and what is types of what is hardness, and what is the types of the hardness, what is mean by the temporary hardness, and what is mean by the permanent hardness. If water containing hardness, how we are estimating that hardness, and after that the specifications of the potable water and steps involved in the treatment of potable water, the 6 steps like screening, aeration, sedimentation, coagulation, filtration, and disinfection. I hope you understand this topic up to this. The next topic I will continue in next session. If you want to refer any books, these are the some of the referred books to helps more understanding this topic. Thank you.